So I've already, oh, where'd it go? I've already prepared a spreadsheet, but let me just build it from scratch, and then if you want to follow along, if I mess up, I can jump over there or jump ahead. Okay, so let's just make up a distribution. I'm just going to say 2.1 is our shape factor, 8.5 is our scale factor. So if you recall, that's k and lambda, okay? And I'll build a distribution real quick. Now, I can use the calls in Excel for this, but I can also use the equations. So remember, you're calling for the wind speed, shape factor, scale factor, and then this is where you get the difference between the distribution function and the cumulative function. So I'll do one of both. So first I'll do false, so that's the one we worked with last time. And then I've got to move everything back. I'm just copying that, and then I'm going to change it to true. And then I got to fix everything in place so that when I drag them down, they don't move. Okay.
What
So
does the dollar sign tell us how you want it to
it says I don't want it to change. When I drag this down, I don't want it to move from these cells. So the one changes the, actually I only really need to use the one because I'm not dragging it this way.
I got you.
Okay, now if I plot this, you can see both of them again. It plots the original data. Okay, so the green bar is your cumulative function, and the red bar is your Weibull. If I get rid of the green bar, you can see the Weibull a little bit better. I'll bring it back in a second. So that was the Weibull for this situation. I'll go back. So that's the cumulative function. So the cumulative function is at this value, it's the sum of all the probabilities before that, and so on. Now, one thing to note is if I just take each, hold on. Let me label. If I just take each one of the probability functions and sum them, is it the same as the cumulative function? What's your intuition tell you? Because this is something I'd see a lot on exams is people maybe taking the harder way of solving a problem solving for several of these steps when they could have just used the cumulative function and yeah.
Are you the cumulative function? Is it just
True. It's using true instead of false in that call. Here, let me, sorry, I always forget to make this bigger. I guess you can't see the, oh, there's the equation. So only thing I changed was that last statement to be true, because it's the same call. It's just, it's asking if it's the cumulative function or not. In this case, I'm saying yes, it's the cumulative function. In the first one, I said false, but they were doing the same thing. So now let me jump to what I already did. Save a little bit of time. Okay, so number one, I want to show you if you use these equations which are in the notes, this one, and capital F stands for the cumulative function, lowercase f stands for the probability density function. If you just use that equation, you get the exact same thing as this function call in Excel. So compare this and this. These are exactly the same, these two columns, right? Okay, so if you're on an exam or if you need to do something by hand or you need to put an equation in somewhere, these do the exact same things. Similarly, probability density function is this equation. These do the exact same things. So you don't necessarily have to use the function calls, I just showed you that, yeah.
So the probability, is that a percentage that's saying that there's a probability that at this wind speed it will create this function?
Yes, so the probability, it's the probability, it's not power, it's this, we're just talking about the probability that the wind is going to blow in that band of wind speeds. So
Cumulative would be like,
it's below that wind speed.
okay.
Okay.
Oh, I see that, okay, so it's counting it all the way to,
Mhm.
all right.
So now, so that's why I give you these equations, because these equations are the same as what's used in this function call. Now, if I just sum up each of the previous values and create like a cumulative function on my own, that's what I've done over here, and then I plotted it, that's the blue. You can see, at first sight, does it look like it's matching? Well, no, if it was matching, it would be right on top of the red. So it's not precisely the same thing. The difference is that the cumulative function is not including the values at the number that you're calling it from. So the cumulative function is going to be a little lower than if I just added up all of these bars. Or maybe it's not that it's below it, but the band that is above is being included. You're overestimating a little bit if you just add those up because of the widths of those bars. Yeah. Yeah, I'm trying. I don't always perfectly finish it, and sometimes I run out of space, but I'm trying to record it. So I usually, when I give an exam problem where I'm asking you for the value between two numbers, I'm looking for you to use the cumulative function, not to add up these values, okay? Because there's a slight difference. I'll give partial credit for that, for sure. I'm not going to call it entirely wrong, but it's going to be slightly, you're doing a more laborious task there, basically. Yeah.
So we just have to use it, for the exam, we just have to use that equation.
Yeah, you'll need to use these equations in the exam, so obviously you can't use a function call in the exam. So that's why I wanted to point out that those are the exact same as what's used in Excel. But if I want to know what's happening at a specific wind speed, or if I'm creating the distribution, then that's when you need the probability function here.